Hello and welcome to the fourth video tutorial of atomic structure. In this tutorial, we will be learning an entirely different topic, which is ionization energy. As the name suggests, ionization energy must have something to do with ions. And something to do with energy too. So, what is ionization energy? Ionization energy is not a big thing. It is just the amount of energy required to change an atom to its ion. So, what is ionization energy? Ionization energy of an atom is defined as the amount of energy required to remove an electron from the atom in gaseous state. Okay, I'll write it down. In this definition, there is a very important thing that we need to notice. That is, from an atom in gaseous state. So, it is only considered ionization energy when the electron is knocked off from the atom in its gaseous state. So, let me write a basic general notation of the ionization energy. Suppose there is an element M which must be in its gaseous state, and when certain amount of energy is applied to it, it changes to M plus ion. The ion is in gaseous state 2 plus electron. So this is the general notation of ionization energy of an element M. Main thing we need to know here is that the element must be in gaseous state and the ion is formed in gaseous state too. Now, what will happen if we try to change this M plus ion to M2 plus ion plus E minus? So, is this also the ionization energy? Many people get confused in this case. This is also the ionization energy. Now, what you need to know here is that the upper notation is called first ionization energy. The second notation is called the second ionization energy. You may get confused here. I am denoting a general element M. It is not the metal magnesium. So many people get confused here when they see M and G together. This is not magnesium, this is an element M. So the upper one is first ionization energy and the lower one is second ionization energy. Now let's read in detail about the first, second and subsequent ionization energies. First ionization energy. First ionization energy means the removal of first electron, which must be from the element. So first ionization energy means the general notation of ionization energy, that is an element M uses electron to form its 1 plus ion. So this is called first ionization energy. Now second ionization energy. Second ionization energy means when the ion formed in the first case loses next electron and forms a 2 plus ion, then it is called second ionization energy. So for third ionization energy, it must be M2 plus ion forming M3 plus ions and so on. So first ionization energy means forming 1 plus ion, second ionization energy means forming 2 plus ion, third ionization energy means forming 3 plus ion, and ionization energy means forming N plus ion. So now let's read about the factors affecting ionization energy and the properties of ionization energy. Let's talk about the property of the energy. Now, since in the definition we have noted that the ionization energy is the amount of energy supplied. Now, supplying energy means the ionization energy is endothermic with sign plus symbol. So ionization energy, standard ionization energy is denoted in this way: delta H IE. So now the first ionization energy is denoted in this way: delta H IE 1, delta H IE 2, and so on. So ionization energy is endothermic, so in each case the value will be plus K plus L plus X, some values, all of its symbol is plus plus plus. Now the major thing you need to know while calculating ionization energy is this. Suppose we consider aluminum and it forms an ion Al3 plus 3E minus. Now if you are asked to calculate the energy change in this reaction, then we need to calculate the first ionization energy, the sum of first ionization energy, second ionization energy, and third ionization energy, because this reaction doesn't take place in one step. First of all, aluminum changes to Al1 plus, and Al1 plus changes to Al2 plus, and Al2 plus changes to Al3 plus. So we need to add the sum of the values of first, second, and third ionization energies. Many people get confused in this case, so please be clear at this point. Now let's talk about the factors affecting ionization energies. There are basically two factors affecting ionization energy. They are: one, nuclear charge, and two, shielding effect. Now let's read in detail about the both factors and how do they affect ionization energy. Nuclear charge means nothing but the number of protons. Now how does this affect ionization energy? If the number of proton is more, then the nuclear charge is more, so the nucleus attracts electron more, hence the removal of electron will be difficult. So the more the nuclear charge, the more the ionization energy, because we'll have to supply more energy. So ionization energy is directly proportional to nuclear charge. And the second case, shielding effect. What does shielding effect means? Shielding effect. So shield means to protect, to cover. Hence shielding effect means how much is the electron shielded from the nucleus, how far is the electron shielded from the nucleus. Let me make a nucleus, and we know that the orbits are around the nucleus. Now there are electrons in the orbits. Now, ionization energy means the removal of the outermost electron, the removal of this electron in this case. Now, if you consider the relation between this electron and the nucleus, the electron is shielded from the nucleus very much because it has 10 electrons inside of it between the nucleus and itself. Hence, shielding effect covers the electron, and for this electron, the removal will be very easy because the nuclear charge, the nuclear attraction will be less because 8 of the electrons are in front of it. So, the shielding effect is inversely proportional to ionization energy. That is, the more the shielding effect, the less is the ionization energy, because the more the shielding effect, the electron will be less attracted towards the nucleus, and hence it will be easily removed from the electron, easily knocked off from the atom. Now, shielding effect. Now, what are the factors affecting shielding effect? The factors affecting shielding effect are just the number of electrons between the nucleus and the valence electron, that is the electron that is to be removed. Hence, the ionization energy depend upon two factors, that are nuclear charge and shielding effect. Nuclear charge is directly proportional to ionization energy, whereas shielding effect is inversely proportional to ionization energy. Now, let's read about the trend of ionization energy down the group and across the period. First of all, let's read the easy case down the group. Suppose we consider lithium and sodium. Lithium has electron configuration of 2-1, whereas sodium has electron configuration of 2-8-1. And now let us consider potassium 2-8-8-1. The atom for lithium will be this, whereas the atom for sodium will be this. 1, 2, 3, 4, 5, 6, 7, 8. Whereas the atom for potassium would be this. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1. Now, if you look closely, then down the group, that is lithium, sodium, and potassium, they are in the same group, that is group 1, and sodium is down below lithium and potassium is below sodium. Now, down the group, the electron is added in the outermost orbital. So, although the nuclear charge increases, because for lithium the nuclear charge is 3, whereas for sodium it is 11, and for potassium it is 19. Although the nuclear charge increases, but since electrons are added to the outermost orbital, the electrons are far from the nucleus, hence the removal of electron will be easier. So down the group, the ionization energy decreases. Why does it decrease? Because the shielding effect wins over nuclear charge. That is, shielding effect wins means that shielding effect will be higher down the group because electrons are added in the outermost orbital. So down the group ionization energy decreases. What will ionization energy be across the period? Now let's look at that. Let us consider period 3, that is elements from sodium to sodium magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Sodium to argon. Now, sodium has an electron configuration of 281, 282, 283, 284, 285, 286, 287, and 288. In this case, nuclear charge is increasing. But what is the change in shielding effect? Now, if you pay close attention, then in each of the case, the shielding effect remains fairly constant. Why does shielding effect remain fairly constant? Because in each case, the innermost, there are just 10 innermost electrons, 10, 10, 10, 10, 10. In each of the 8 elements, the innermost electrons are, the number of innermost electrons just 10. And since the number of innermost electrons is same in each case, the shielding effect remains fairly constant. Now, nuclear charge is increasing, shielding effect is constant. So across the period, the shielding effect, the ionization energy increases. Ionization energy increases across a period. So ionization energy is no big deal. It is just the removal of electron, and you need to know the trend in ionization energy. Next up, we will be learning about deducing electron configuration of an element from its ionization energy. We know that ionization energy is exothermic. That is, we need to supply energy to remove electron. Ionization energy is endothermic. Now we need to know a little bit more thing than this. The value of ionization, successive ionization energy increases in each case. The value of successive ionization energy increases. That is, the value of ionization energy 1 is less than ionization energy 2, and ionization energy 2 is less than ionization energy 3. That is, which means third ionization energy is greater than second, and second ionization energy is greater than first. The trend is very simple. This happens because in each case, when one electron is removed, there will be less number of electrons. So now the nucleus attracts the less number of electrons more tightly. Hence, the removal of next electron will be difficult. So the successive ionization energy value increases. Now there is a trend in the increment too. Suppose consider metal, aluminum. Aluminum has electron configuration 283, and now let us make a rough diagram of its atom. 2 electron in its innermost orbit, 8 in the middle one, 5, 6, 7, 8, and 3 in the outermost orbit. When one electron is removed from it, now the electron is removed from the outermost orbital. Suppose this electron is removed. First ionization energy. It means first ionization energy. Now, first ionization energy means the aluminum is changed to Al plus gas plus electron. And now, when you remove the second electron, the electron is still removed from the outermost orbit. That is, from this orbit, this electron will be removed. Ionization energy 2. Second ionization energy means Al plus changing to Al2 plus. Now, third ionization energy means the removal of this electron, which means Al2 plus changing to Al3 plus. Now, when you try to remove the fourth electron, then the electron must be removed from the inner orbit now. If you look closely, then the nuclear charge in the third orbit will be less compared to the second orbit, nuclear attraction. So, when all the electrons from the outermost orbit are removed, then the removal of fourth electron in case of aluminum becomes very difficult. So, there is a high change in ionization in the third and the fourth ionization energy. Third and fourth have very high change because aluminum has 3 electrons in its outermost orbital, and when you try to remove the fourth electron, then you must have to supply a very high amount of energy. So now this basic thing helps us to reduce the electron configuration of any metal, any atom, any element from its successive ionization energy values. Suppose I'll write a successive ionization energy of certain element. This is not the real successive ionization energy. I'm just guessing it and writing it down. This is the first ionization energy, this is the second ionization energy, this is the third ionization, this is the fourth ionization energy, this is the fifth, and this is the sixth one. Now the question is asked, the element represented by the following ionization energy falls in which group? To know that, we need to look where there is a vast change in the ionization energy of that atom. So 3400 to 7800, it is at a vast change. 7800, there is no vast change between these two and this, but there is a vast change between this fifth and the sixth ionization energy. There is vast change between fifth and sixth ionization energy, which means that the given element has 5 electrons in its outermost orbital and the sixth electron lies in the inner orbital. Hence, the element represented by this ionization energy falls in group 5. So in this way, we need to find out in which group the element lies. So it is a very difficult concept. Ionization energy is very simple. So the basic thing we learn here is what is ionization energy, the notation of ionization energy, and the nature, that is ionization energy is endothermic, the factors affecting ionization energy, and how to deduce which element it is, or how to deduce the element falls in which group from the ionization energy of that element given. So these are the basic things you need to learn in this chapter, atomic structure. Thank you.